Over the last several years, new IC packaging technology has revolutionized the industry. With that, the need for a repair station with repeatable process control at a reasonable price became increasingly important. Well, it's finally here. The Chipmaster SMD-1000 is manufactured by the Automated Production Equipment, or APE Corporation, and is currently available through the Motorola Worldwide Parts Organization. This repair station utilizes a microprocessor-controlled, closed-loop heating system with a pre-programmed temperature ramp-up that gives the user precision control across the entire envelope of SMD repair and rework parameters. Once up to temperature, the unit will maintain the set temperature to plus or minus 1 degree centigrade. Before we actually demonstrate removing and replacing an IC, let's take a moment to discuss the controls. Starting at the front panel, you notice the controller display, which is located in the upper left-hand corner. The controller is fully programmable, so you can customize the profile to meet your needs. As you can see, 2 numbers are shown on the LED display. The number in green is the operating temperature the machine is set to operate at. The number in red is the current temperature of the air passing through the heat focus head. To the right of the display is the main power switch. Below the display is the vacuum director control, and below that is the vacuum pump control. Moving over to the heater tube assembly, you notice the spring-loaded vacuum pickup. A foot pedal, which is plugged into the back of the unit, activates the heater. A spring-loaded circuit board holder is provided that will accommodate a circuit board approximately 8 inches square. In addition, 3 common focus heads are included with the machine. Now, for those of you that are interested in the technical specifications, the unit is constructed with an anodized aluminum body with a solvent-resistant polyurethane finish. It meets all UL, CSA, and foreign electrical code standards. The power supply is available in the 120-volt or 220-volt configuration. It incorporates a 1200-watt heater assembly and has a self-contained vacuum pump. Physically, it is only 23¼ inches long, 9 inches wide, 7 inches high, and weighs 14½ pounds. Finally, it is fully grounded and, above all, ESD safe. When you receive your unit, you will find the controller has been pre-programmed for most Motorola IC profiles. This doesn't mean you can't make some modifications if you need to. The 2 most common reasons to reprogram the controller would be to change the operating temperature set point and to reset the timer. A word of caution, though, regarding changing the operating temperature. Several of the new ICs are manufactured on a printed circuit board substrate as opposed to a ceramic substrate. This can present a problem if the IC is heated too hot too fast. Always check your product manual for specific temperature settings. With the new IC technology, applying extra heat to get it off quicker is the worst thing you can do. To change the operating temperature set point, begin by turning the unit on. The controller will go through a self-test, then 2 numbers will be displayed. As mentioned before, the top number in red is the temperature of the air flowing through the heat focus head. The bottom number in green indicates the operating temperature set point. To change the set point, press the index button twice. The display will now read the set point temperature in red and SPI in green. To change the temperature value, press the up or down arrow key until the desired temperature is reached. Once the desired temperature is reached, press Enter to program the new setting. Pressing Index again will return you to the main menu. To activate the timer, press the Enter and Down arrow keys simultaneously. You should see the display flash once. Next, depress the foot pedal to activate the heater. Notice the set point temperature disappears and it is replaced by a timer. The top number in red will begin to increase, indicating the temperature through the heat focus head is rising. Once the foot pedal is released, the controller will retain the amount of time the heater was on until the pedal is pressed again, at which time the timer begins to count back to 0. In theory, removing and replacing a component should take the same amount of time. To clear the timer for another component, simply press the Enter and Down arrow keys simultaneously. Let's say, for example, you have to rework several circuit boards by changing out the same IC on each board. After you complete the first one, the controller will still retain the time it took to remove the IC. Each additional press of the foot pedal will start the timer counting back to 0, and it will continue to operate in this manner until it is reset. Are you ready to see how easy the unit is to operate? Okay then, let's try making a few repairs. The first thing you need to do is to place the circuit board in the circuit board holder. To do this, loosen the set screw on the movable arm and slide the arm until it is almost as wide as the circuit board. Then tighten the screw to lock it in place. Next, depress the spring-loaded piston on the edge of the fixture to open the arms wide enough to accommodate the circuit board. Slide the board in place and release the piston. Selecting the appropriate heat focus head is next. In the past, many people have spent a lot of money buying every focus head available. This is not necessary. This unit comes with 3 different size heads that should work for most applications. When selecting a focus head to remove an IC, choose a head that is approximately the same size as the IC. If the exact size focus head is unavailable, select one that is slightly larger. Then connect it to the heater assembly. Next, loosen the set screw on the vertical positioner of the circuit board holder. Slide the fixture under the heat focus head and adjust the holder so that the circuit board is approximately 1/8 to 1/4 of an inch below the focus head. Tighten the set screw. Center the IC that is to be removed under the focus head. Lower the spring-loaded vacuum pickup until it touches the IC and activate the packing pump. Finally, depress the foot switch to activate the heater and sit back and wait. Once the part is lifted, gently slide the circuit board holder out from underneath the focus head. Lower the vacuum pickup, grab the IC with a pair of tweezers, and turn off the vacuum pump. Then set the part aside. The IC should release in approximately 50 to 60 seconds. If the IC releases in the 30-second time frame, you need to slow the process down. The easiest way to do this is by slightly lowering the circuit board holder. Keep in mind that as you lower the circuit board, you will be heating up more of the adjacent components. Once the component has been removed, the next step would be to clean the solder pads. This can be done by using either a power desoldering tool set at approximately 750 degrees or solder wick and a soldering iron, also set at approximately 750 degrees. Make sure when you are cleaning the pads that you are careful to remove all of the solder from the pads. Some people get carried away and end up removing all the pads from the board. If done properly, the solder pads on the circuit board should be completely flat and free of all solder. The importance of this will become quite apparent in just a minute when we try and align the new chip carrier. The IC we have chosen to replace is an OMPAC, which stands for Over-Molded Pad Array Carrier. Before we go any further, I need to point out that it is very important that you receive and store these devices in a sealed, dry, anti-static bag. Exposing these ICs to moisture for more than 96 hours could result in the IC delaminating during the repair procedure. With this OMPAC, all the solder connections are underneath the carrier, which makes aligning it a challenge. It's not as difficult as it may seem, though. First of all, the IC will self-align as long as 50% of a solder ball on the chip carrier is on a circuit board solder pad. What this means is close is good enough. Second, where there is room, you will find location marks on the PC board. Okay, let's try it. We've checked the maintenance procedure in the product manual for this product and found that before you replace the IC, it needs to have a solder paste flux applied to it. Remember, it is possible that different products will recommend different procedures for replacing a particular IC. Always check the maintenance procedures in the service manual before replacing an IC. Once the solder paste flux has been applied, the IC is ready to be placed on the circuit board. Carefully center the IC over the circuit board pads. If a location mark is present, position the IC so that it is aligned with the horizontal and vertical marks. This is where you could have problems if you haven't cleaned the pads properly. Any bump of solder left behind causes the IC to slide off that pad. Once aligned, carefully slide the circuit board holder back under the heat focus head. Position the board so the IC is directly underneath the focus head. Activate the heat by pressing the foot pedal and wait. In approximately 50 or 60 seconds, the IC will settle ever so slightly. Gently tap the circuit board to relieve any surface tension. Slide the board out from under the focus head and wait several seconds for the board to cool. Inspect your work, and you're done. Now that wasn't so hard, was it? Like anything else, it takes practice to build your skill level. Okay, now what if the circuit you need to troubleshoot is under a shield? How do you get them off? That's easy. Again, you need to place the circuit board in the circuit board holder. Next, select a heat focus head that is approximately the same size as the shield. In most cases, you won't have a focus head big enough. Don't worry, select the biggest one you have that doesn't exceed the size of the shield. In this case, we've selected one that is about 50% smaller than the size of the shield. Remember, the shield is a big piece of metal that conducts heat very well. That is why it is not important for the focus head to be exact. Once you have the appropriate focus head selected, attach it to the heater assembly. Before you slide the board under the heat focus head, brush a small amount of Kester Flux Formula number 197 around the perimeter of the shield. Position the shield under the heat focus head in the same manner as you did when you removed the IC. Now lower the spring-loaded vacuum pickup until it touches the shield and activate the vacuum pump. Finally, depress the foot switch to activate the heater and sit back and wait. Once the shield is lifted, gently slide the circuit board holder out from underneath the focus head. Grab the shield with a pair of tweezers and turn off the vacuum pump. Then set the shield aside. Removing this shield took much longer than the IC. The main reason for this was the fact that the focus head was approximately 50% smaller than the shield. The purpose of selecting this head was to prove that a smaller head will work. It will just take longer. With the shield removed, take a soldering iron and smooth out the remaining solder on the circuit board. Then wipe the soldering iron around the edge of the shield, which will flatten any remaining solder that is left behind on it. Replacing the shield is quite simple compared to replacing an IC, due to the fact that aligning the shield is not as critical. Before you place the shield on the circuit board, reapply the Kester liquid flux to the solder pad on the circuit board. Place the shield over the solder pad and slide the circuit board back under the focus head. Adjust the position of the shield so it is centered under the focus head for optimum heat transfer. Depress the foot switch to activate the heater and wait until the shield reflows. Notice no extra solder was added. This is due to the fact that there was enough residual solder left on the pad and shield. After reflow occurs, gently tap the board to relieve any surface tension. Gently slide the board out from under the focus head and wait for it to cool. The last item we are going to remove and replace is a TSOP component, which stands for Thin Small Outline Package. This type of package is probably the most difficult IC to replace. As you can see, the IC is a leaded device. This normally is not a problem, but the leads on this IC are on approximately 11 millimeter centers. That means the space between the leads is approximately 8 millimeters. Obviously, you need to be extra careful when you align this one. Removing the IC is done in the same manner as the OMPAC. Begin by selecting the proper focus head, then connect it to the heater assembly. Place the circuit board in the circuit board holder and position it so the IC is centered under the focus head. Lower the vacuum pickup until it touches the component and activate the vacuum pump. Depress the foot switch to activate the heater. In approximately 50 seconds, the IC should lift off the circuit board. Once the part is lifted, gently slide the circuit board holder out from underneath the focus head. Grab the IC with a pair of tweezers and turn off the vacuum pump. For this IC, we are going to add a small amount of the Kester liquid flux to the solder pads on the circuit board, then slide the circuit board holder back under the focus head, centering the solder pads of the IC under the head. Depress the foot switch to activate the heater and wait for the solder on the pads to reflow. Once complete, gently slide the circuit board holder out from under the heat focus head and let it cool. Now, here's the tricky part. Placing the new component on the pads. Remember, with the OMPAC, close was good enough. With this IC, you have to get it right on. Take your time and use a magnifier if you have to, because it has to be right. Apply a small amount of Kester liquid flux to the solder pads on the board. Next, carefully place the IC on the pads. Slide the circuit board holder under the heat focus head, making sure to center the IC under the head. Depress the foot switch and wait for the component to reflow. Again, no extra solder was needed. Once complete, gently remove the circuit board holder out from under the focus head. Let it cool, and then inspect your work. Hopefully yours was successful the first time. If there are any solder bridges, use a micro-tipped soldering iron to clear them. If a solder joint looks questionable, you can also touch it up with a soldering iron. Just be careful because the pads are very close together. The Chipmaster SMD-1000 is available through the Motorola Worldwide Parts Organization. The part number for the 120-volt version is R1319A and R1321A for the 220-volt version. In addition, parts carry several different heat focus heads and accessories for the machine. So there you have it, a product that is priced right, small enough to fit on your repair bench, and easy to operate. As technology advances, there is going to be an increasing need for a product like the Chipmaster SMD-1000 to meet all your repair needs.